Hey everyone, welcome to The Explainer. We're going to take a task that every sysadmin out there knows like the back of their hand, setting up a network device, and we're going to look at it through a totally new lens. We're not just treating it as a setup, but as a critical security procedure right from the very first boot.
So let me ask you something. As an experienced sysadmin, when does network security really begin? Is it when you set up the firewall, configure some access lists? Nope. The real answer? It starts the instant you power on a new device for the very first time.
So we're going to follow this pretty standard workflow, right? Initialization, configuration, routing, and verification. But here's the twist. For us, each of these steps is a security checkpoint. Think of it as our roadmap for hardening the network from the ground up before it ever even sees a single byte of production traffic.
All right, let's jump right in. Security starts with that initial boot sequence, the device's very first breath. So what's actually happening under the hood? And more importantly, where's that first potential crack in the armor?
You know this sequence. It's pretty much automatic. The post, the bootloader, CPU in it, flash in it, and then loading up the OS. But what I want you to zero in on here is step 2, the bootloader. That is our first potential security gap. It's where control of the device is really established, and it's our first chance to lock it down.
And here's the bottom line. It's actually super simple. Whoever controls that bootloader controls the entire device. And guess what that control really comes down to? One thing: physical access. That's it. That's your first and maybe most important line of defense.
Think about the disaster recovery process. It's an absolute lifesaver, right? You've lost a password, maybe you've got a corrupt OS. But that exact same procedure, that lifesaver, becomes a massive vulnerability in the wrong hands. It's a wide open door for an attacker to just walk in and take over the whole show.
And this right here shows you exactly what I mean. The physical entry sequence on the left, all it takes is holding down a single button, the mode button, while it powers up. That interrupts the normal boot process and drops you right into the bootloader prompt you see on the right. Just like that, you've bypassed the entire OS and all of its security.
Okay, so we've talked physical. Now let's shift gears to the management plane and start building up our defenses in the digital world. Once the device is booted, we gotta manage it, and we have to do it securely.
So obviously we need to manage this thing remotely. And on a switch, we do that by creating a logical switched virtual interface, an SVI. We'll pop it into VLAN, give it an IP address, and then, and this is key, we use the no shutdown command to actually bring it to life. This is our digital doorway into the device.
But how we guard that doorway? Well, that changes everything. Just look at this. On the left, a packet capture from a telnet session. You can literally read the username and password in plain text. Anyone sniffing the network can see it. Now look at the SSH session on the right. It's just a jumble of encrypted nonsense to an outsider. The difference is, well, it's night and day.
Look, this isn't a suggestion. It's not a best practice. It is a hard, fast rule for any modern, secure network. There is absolutely no reason, no excuse to be using Telnet for management access, period.
So what's the fix? It's this pretty straightforward 6-step process. You set a domain name, you generate your crypto keys, create a local user, and then you configure your V2I lines to accept only SSH connections. That last step, enforcing SSH version 2, just slams the door shut on any older, weaker versions.
Okay, so we've built our defenses, right? Both physical and logical. But we can't just trust that they're working. We have to verify. We need to audit our own work and make sure everything is locked down exactly how we think it is.
And these common show commands, they're not just for troubleshooting when something breaks, they are your frontline auditing tools. You run show IP interface brief, and you're looking for that up/up status. That confirms your physical and data link layers are solid. Then, a quick show IP route confirms your layer 3 is configured just the way it should be.
And it's the exact same idea for IPv6. You've got to verify the addresses. Is the global address correct? Has the link local address been properly generated? Checking these details confirms the interface is up and running, but more importantly, that it's operating strictly within the lines of your security policy.
Now this is a sysadmin's best friend, the filter pipe. Instead of drowning in hundreds of lines of output, you use the pipe to act like a scalpel, cutting right to the chase. You can include, exclude, or start from a specific line. It turns a long, tedious security check into something you can do in seconds. It's incredibly powerful.
So, at the end of the day, what's the big takeaway here?
It's that just getting a connection to work isn't the finish line. A hardened, audited, and defensible connection is. When you start thinking that way, that vigilance turns a boring old setup task into a foundational security practice. And it all starts from the second you plug that power cord in.